Hello, everyone. In this video, we're going to begin section 8.2 on geometric series. So in this section, we're going to see the definition of series and a particular type of series called a geometric series. But before looking at that definition, I want us to get started with example 1, where we're introduced to this topic in a context. So let's look at that example. So example 1 says, a patient taking an anti-inflammatory drug takes one 100 milligram tablet every 3 hours. It is known that at the end of 3 hours, about 10% of the drug is still in the body. So the rest of the drug, the 90% that's not in the body, was metabolized by the body. So in part A, what we want to do is find an expression for QN. Well, what is QN? QN is the amount of the drug present in the body right after the nth tablet is taken. So I'm just going to highlight some of the important information here. So a tablet contains 100 milligrams. The person is going to take one every 3 hours. And at the end of 3 hours, about 10% of the drug is still in the body. So let's get started on part A by looking at some terms in this sequence. So we can call this QN a sequence because it's just going to be a list of numbers. Those numbers are representing the amount of the drug in the body. Okay, so let's look at a few numbers in this list. So let's begin with Q1. So Q1 is just the amount of the drug in the body after the first pill is taken. So at this point, we just have 100 milligrams of the drug in the body. So this is the amount after the first tablet. Okay, so then what happens? How do we compute Q2? Well, at Q2, we've taken the second tablet, so that means 3 hours has passed. So at that 3 hour mark, we're going to take that second tablet, so we have that 100 milligrams now in our body, but we still have 10% of the first pill in our body. So that would then be 100 milligrams, but times 10% or 0.1 of it. So if we compute that out, 100 times 10% is 10, so we get 110. So this is the amount after 2 tablets. All right, let's look at Q3. So at Q3, we're taking the third tablet, so that means another 3 hours has passed. But with that third tablet, we have that 100 milligrams now in our body. We have 10% of the second pill that we took up here, 10% of this pill. But then we're also going to have 10% of 10% of the first pill, because as each 3 hours moves, 10% of that tablet, or what's left of it, is in our bloodstream. So then the effect of that first pill we took will be 100 times 10%, which was there 3 hours ago, but then times another 10%, because we only have 10% of that pill. So we can simplify this a bit and just write 100 plus 100 times 0.1 to the power of 1 plus 100 times 0.1 squared. Okay, and what does that become? Well, we have 100 plus 10, that's 10% of 100, plus 10% of 10%, so that'd be 10% of 10, so plus 1. So we have 111. That's the amount after third tablet. Okay, so let's go ahead and do one more together here. And maybe I encourage you to pause the video and see if you can work out Q4 on your own and then compare your answer. So Q4, we've taken our fourth tablet. Another 3 hours has passed. So we have the 100 milligrams from that fourth tablet we've just took. Then we have 10% of 100 from that third tablet. We have 10% of 10% from that second tablet. And we have 10% of 10% from that original first tablet we took. All right, so simplifying this, we could write 100 plus 100 times 0.1 to the 1 plus 100 times 0.1 squared plus 100 times 0.1 to the third power. So that would be amount with fourth tablet. All right, so if we calculate all that up, we're going to get 111.1. All right, so we can keep doing this, but what's going to be helpful is if we have a general form for what Q sub n is going to be. So maybe take a moment to reflect on the Q's, Q sub i's that we've just created, and see if you can find any pattern. Well, one thing we can observe, so if we look, say, at this Q4, we notice that Q4 is created by adding up some numbers. And these numbers, these terms, is there any pattern that we see here? We see that we always start with a 100. I'm going to use a different color here. We always have a 100 first, plus 100 times 0.1, plus 100 times 0.1 squared. We're adding up terms that look like this, but then where do we stop? Well, notice when we've taken the fourth pill, we have 4 terms, 1, 2, 3, 4. But notice what happens in the exponents. So here, this is kind of like an imaginary 0.1 to the 0. So each of these terms looks identical, but the exponent just increases each time. With the fourth tablet, we only go up to 3 because we're also counting that 0th pill, or the pill that we've just taken as kind of the 0th one. So that's why our index at the end of this exponent is 1 less than the pill that we're on. So we'd add up all the way to 100 times 0.1 to the n minus 1. All right, now that doesn't look too bad, but it turns out there's an even simpler way we can write this. So when we have a term like this Qn, that's a sum of a bunch of terms that has a pattern that we can identify, we can write that term, that's a big sum, in what's called summation or sigma notation. So what does that look like? So that looks like the following. So we can write Q sub n with a sigma. So this symbol is a Greek letter sigma that stands for, in mathematics, taking a sum. And so now here next to that sigma, we're going to write what the general form of a term looks like. Well, if we notice, a general form of a term looks like 100 times 0.1 to some power, and I'll call that power k. But now k will change for each term in our sum. So what does k start with? Well, k starts with 0 for our first term, because again, this is like an imaginary, not imaginary, it's present, but we could write 0.1 to the 0. So that k begins at 0 and then goes all the way up to n minus 1. So here's a more compact way to express that Qn term.